Hello, I'm excited to be here today to talk about integrating innovation in bridge inspections, utilizing unmanned aircraft systems, and also advanced analytics. So, first of all, let's talk about how unmanned aircraft systems has really innovated the way that we're working in bridge and structure inspections. So, to do that, first of all, let's look at a history. Let's go back to the beginning of the drones. If you look at 1940, back in 1940, actor and hobbyist Reynold Denny sold 15,000 radio controlled target drones to the US military to train anti aircraft gunners for World War II. Back in 1940, if you look at the timeline, things go up. You started seeing them used more by the military. Then, about 2010, Parrot started creating an AR drone. They went from there. They showcased it in the Las Vegas. Then, as you keep propagating up, Amazon came out, said they're going to do package deliveries, revolutionize the way that we're actually getting packages delivered, which is starting to happen now. And then also, if you look at the statistics, every DOT is now utilizing UAS in one form or another. Very exciting time. Very exciting for DOTs. And I believe this technology is going to really save lives. I've seen it. You're off the road, you're not in harm's way. Not only that, they're saving money and creating that return on investment that you need for these new technologies. And really, they're going to revolutionize the way we live and work. So, as we're getting into bridge inspections, let's talk about some of these challenges. Where can UAS really help us? How can they do, or I should say, how can they be a tool in the toolbox to help with these bridge inspections? So, if you look at these different things here, some of it could be you have hard to reach areas. Maybe it's the depth of the structure or the height. It's very tall. You have to normally get climbers, or you have to utilize other technology or high resolution zoom from the ground and you can't get the right angle. Maybe it's utilities or other items that are blocking it. Maybe it's just hard to access due to water or other items. There's a lot of challenges involved with these bridge inspections, and that's where we're really seeing UAS shine. They're able to get close to this. We've have ones that have radar on them that they can fly in GPS denied environments now, get up close and personal with it. And you're not having to shut down traffic a lot of times. There's not having to have traffic control. You're saving costs there. And not only that, they're finding errors or issues that we've missed otherwise doing it the traditional way. So it's just another tool in our toolbox to really help us supplement and revolutionize the way that we're really doing these inspections. So with that, let's do a comparison. So if you look at these different photos, you can see a comparison on the bottom with traditional photos versus with the UAS. So as you can see, the UAS can get up a little bit more closer. And not only that, they can get a different angle. I think that's key. They can get into some of these angles you can move back and forth, where sometimes it may be really hard to do that when you're in a snooper truck or some other items to get some precision areas. It may be difficult to do that. So as you can see, you can get right onto it, get good documentation, and it's really a lot faster, and you're not having to worry about traffic control again. So that's just some comparisons there on it. Let's look at the quality of it. So as you can see over on the left here, we've got a composite of all the images put together. And in the middle, you're seeing one from rope access. So they have to climb and go down to where on that angle they could get on the bridge. They do their best job that they can, but as you can see, the angle's not quite right. You can see something, but if you look at the snapshot from a UAS, it can get right on the face, look up close. You can even use zoom cameras and get even closer. What you're looking at right here is 1/32nd of an inch. This crack right here, you're also seeing some of the staining from a rust stain there. So you're really seeing how the dynamics of the data is changing and creating a new tool for our inspectors. Not only that, one really neat thing is we're identifying defects that we've missed using traditional methods. Here is a great example of it. We were flying this particular bridge. It had some concrete that was falling in other areas. We had to close down the lanes. And what we did is we wanted to really look and see what our thermal camera could do. This is a higher resolution one. So we flew it over the deck, and we were actually able to identify a delamination that we'd missed with traditional sounding methods. So you can see it identified here. After that, we took one of our hammers, pounded on it, and sure enough, there was a delamination there that we'd actually missed doing traditional methods. So it's amazing what we can see with these, and you can do it without even closing traffic. Now, there's some considerations with where the sun's at, how that might affect it with the properties when you're getting the different heating and cooling cycles. But overall, we're really seeing good results, and we're just really touching the tip of the iceberg on this, really. So as we look at that, Where can we go? We've seen great performance enhancements. We're seeing safety. We're seeing these other items. We've got great UAS platforms and we got good sensors with zoom cameras and thermal. Where do we go? What is our next steps? What is the next progression in this evolution on here? So with the data, it's we've got it collected. So let's look at some of the items they're taking it. So here you can see the imagery is all stitched together. As we take this, we can bring that into CAD. We can start to do our sketches from the imagery in there that's all geo-referenced and make a better analysis of it. It's not a sketch out in the field that sometimes is harder to decipher what's there, what's not, what's the location of it. You can get all that here. Now, again, this is 2D though. What else can we do? We also can create these 3D models. So you have the contextual awareness of a full 3D model to be able to move it and rotate it, and you can label it. You can also still put your sketches in here. You can combine it with your hands-on inspection to create these sketches in your CAD. So there's multiple theses that you can do with this data. As we go on to this, everybody wants to know about cost. We did a cost comparison of using industrial rope access versus UAS. Now, if you look here, we got a concrete pier inspection, and here's the days required. So it took 1 day for rope access, and this is just one pier. And you can see our unit costs. So it would have been $3,500 for rope access. For a drone, it was 0.25 days for that one pier. Unit cost is 2,500. Fill cost 625. Time required. So this is in hours, right? So if you look at this, it was $2,125. Now, if you propagate that out to all the piers, so the drone did it in 3, where the rope access was 7. If you look at the total savings on that, over $12,000. Let's look at a suspender rope inspection. Again, on this one, you can see it took 3 days to do rope access. The drone was able to achieve it in 1 day. If we look to all the ropes, this is just a single one. If you look to all the ropes, the savings here, the drone took 4 days. Rope access took 24 days. Look at these savings that we've seen on here, 18,000 versus 76,000. That's a total savings of $58,000 that we realized by utilizing UAS. As you propagate that out to all your bridges, it's staggering the savings you're seeing. Not just the savings, though, as I mentioned earlier, the life-saving piece. If you can save one life, it's also worth it. We're getting out of harm's way. We're finding defects that we may have missed otherwise. And on top of that, we're seeing these savings. And really, the key on this is, where do we go from here? We already had the next steps. Okay, we got the data collected. What do we do with that data? How can we push that envelope further? What can we do to really innovate and get this to get even more returns of what we've seen? So let's discuss some of this on your advanced analytics. So I'll give you a little background on this job, and I'll give you 2 pieces. I was working on this overhead sign inspection. It was on I-80 and 201. So we were able to fly from the side of the road. And by flying on the side of the road, we didn't have to set up traffic control. Instead of doing 2 signs at night like we traditionally did, we were able to do 16 signs in one night. So you can see the savings there alone. Not having to have traffic control, getting the job done quicker. On this particular project, we saved over $100,000. We were quite amazed by how efficient we were on this. Now, take it to the next level. This is the 100,000 we saved just on the data collection. But if you look at these other photos, this is what I really wanted to point out. Then we looked and said, okay, we've got our team looking at this data, and it's very time consuming. So what can we do to improve that? So we looked at AI and machine learning and train the model and let it find the defects. So it was able to, from our training models, find the missing rivets, find welds that were broken or not in place, and help so we could supplement what our structure inspection team was doing by using the computer where it's strong to increase that efficiency even more. And you can see how it's identified these, and then the level of confidence. So it's amazing what can be done. We also propagated this out into crack detection as well, as you can see here on the bottom right photo. So utilizing that is the next step in this evolution of it, is using AI and machine learning. I really want to show you some neat advancements that Colorado State has done. So again, they're taking the data collection piece, putting it onto the data servers. Then they take this data processing module, right? You've got your BIM data, your photos, other items. You put it in here into your inputs, right? Again, your photo, video, your GPS tags, and they break it down into element IDs from these 3D models, broken down into a 3D element. From there, they can do the defect detection, automate it again. It's all automated with machine learning and AI. And what they can do is once they've got these defect detections there, they can see how things are changing or growing over time and predict the life cycle of a bridge. So you can predict better and more reliably when you may have failures or when it needs to be replaced to get it in that schedule. Quite amazing what they're doing. I've got the paper link down here, but if you want to read on that, it's streamlined bridge inspection system using unmanned aerial vehicles and machine learning. So great paper to read. We've been working with them. Excited to answer some questions you have on a lot of the AI and other things as well during our session. And with that, I thank you. Excited to be here and excited to answer any questions you may have.